According to the 2004 National Electrical Code, Article 300.5, direct buried conductors are permitted where they are not subject to physical damage. However, when the conductors are subject to physical damage, they must be installed in a raceway or otherwise protected. Conduit is a type of raceway offering physical protection for the wires. This means that for running a terminus 3 wire with ground to a storage shed underground, either direct burial or installation within a conduit is permissible, contingent upon the risk of physical damage. If the location of the direct burial wire is such that it is unlikely to be disturbed or damaged by digging, vehicle traffic, or other hazards, direct burial may be acceptable. However, if the wire runs through an area where damage is more probable, using conduit becomes the preferred method. A decision to use direct burial or conduit involves assessing the specific conditions of the installation site. Direct burial can be more cost-effective and less labor-intensive because it does not require the additional step of installing a conduit. However, it might require the use of direct burial rated cable, which is specifically designed to withstand the harsh conditions of being buried underground. This type of cable has a robust outer jacket that resists moisture, chemicals, and abrasion. When considering direct burial, it is important to adhere to the National Electrical Code guidelines for burial depth. These depths vary depending on the voltage of the circuit and the location of the installation. Generally, higher voltage circuits require deeper burial depths to prevent accidental contact and ensure safety. Additionally, it is crucial to mark the location of the buried cable with warning tape or other suitable means to prevent accidental damage during future digging or excavation activities. On the other hand, using conduit provides a higher level of physical protection for the wires. Conduit is a rigid tube typically made of metal or plastic that encases the wires and shields them from impact, moisture, and other environmental factors. There are several types of conduit available, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and rigid polyvinyl chloride conduit. Each type has its own advantages and disadvantages in terms of cost, durability, and ease of installation. When using conduit, it is important to select the appropriate type for the specific application and to install it according to the National Electrical Code guidelines. This includes properly supporting the conduit, using appropriate fittings and connectors, and ensuring that the conduit is adequately grounded. Conduit offers the advantage of being replaceable and upgradable. If the wires inside the conduit become damaged or need to be replaced, they can be easily pulled out and new wires installed without having to dig up the entire trench. Similarly, if there is a need to increase the capacity of the circuit, additional wires can be added to the conduit as long as it is not already full. Furthermore, conduit provides a continuous grounding path for the electrical system. This helps to prevent electrical shock hazards and ensures that the circuit breaker will trip in the event of a fault. The grounding conductor within the conduit must be properly connected to the grounding electrode system of the building to provide an effective ground fault current path. When making the decision between direct burial and conduit, it is also important to consider the local regulations and requirements. Some jurisdictions may have specific rules regarding the installation of underground wiring, including the type of cable or conduit that must be used, the burial depth, and the marking requirements. It is always best to consult with a qualified electrician or local building inspector to ensure that the installation complies with all applicable codes and regulations. In summary, the 2004 National Electrical Code permits both direct burial and conduit for running power to a storage shed underground. The choice between the two depends on the level of physical protection required, the specific conditions of the installation site, and the local regulations. Direct burial can be a cost-effective option when the risk of physical damage is low, while conduit provides a higher level of protection and allows for easier maintenance and upgrades. It is essential to carefully assess the pros and cons of each method and to consult with a qualified electrician to ensure a safe and compliant installation. Consider the soil conditions, the likelihood of future digging or construction in the area, and the potential for rodent or insect damage. All of these factors can influence the long-term reliability and safety of the underground wiring system. Also, remember to use the correct size wire for the intended load. A Temenis 3 wire with ground is a common choice for many shed wiring applications, but it is important to calculate the expected amperage draw of all the lights, tools, and appliances that will be used in a shed to ensure that the wire is adequately sized. Using an undersized wire can lead to overheating, voltage drop, and even fire hazards. The 2004 National Electrical Code provides tables and guidelines for determining the appropriate wire size for different amperage ratings and circuit lengths. These tables take into account the type of wire insulation, the ambient temperature, and the number of current-carrying conductors in the raceway or cable. It is always best to err on the side of caution and use a larger wire size than is strictly required to provide a safety margin and minimize voltage drop. Voltage drop is the reduction in voltage that occurs along the length of a wire due to its resistance. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and electronic equipment to malfunction. The amount of voltage drop depends on the wire size, the length of the wire, and the amperage of the circuit. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. There are online voltage drop calculators that can be used to estimate the voltage drop in a circuit and determine the appropriate wire size. In addition to wire size and conduit selection, it is also important to use the correct type of fittings and connectors for the underground wiring installation. These fittings and connectors must be rated for underground use and be suitable for the type of wire and conduit being used. They should also be properly installed and tightened to prevent moisture from entering the system and causing corrosion or electrical faults. When connecting the underground wire into the main electrical panel, it is important to use a properly sized circuit breaker or fuse to protect the circuit from overloads and short circuits. The circuit breaker or fuse should be rated for the amperage of the circuit and should be installed in accordance with the National Electrical Code guidelines. It is also important to label the circuit breaker or fuse so that it can be easily identified in the future. Furthermore, ensure that the shed is properly grounded. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock hazards. The grounding system should consist of a grounding electrode, such as a ground rod or a metal water pipe that is connected to the grounding conductor in the electrical panel. The grounding conductor should also be connected to the metal frame of the shed and to any metal enclosures or equipment inside the shed. All electrical work should be performed by a qualified electrician who is familiar with the National Electrical Code and local regulations. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock, fires, and other hazards. A qualified electrician has the knowledge, skills, and experience to safely and correctly install the underground wiring system and ensure that it meets all applicable codes and regulations. Remember to obtain the necessary permits and inspections before starting any electrical work. Many jurisdictions require permits and inspections for electrical installations to ensure that the work is done safely and in compliance with the applicable codes. Failure to obtain the required permits and inspections can result in fines, delays, and even the removal of the work. The permit process typically involves submitting plans and specifications for the electrical installation to the local building department and paying a fee. Once the permit is approved, the work can begin. During the inspection, a building inspector will verify that the work has been done in accordance with the approved plans and specifications and that it meets all applicable codes and regulations. If any deficiencies are found, they must be corrected before the inspection can be passed. In addition to the above considerations, it is also important to plan for future expansion and upgrades. If there is a possibility that additional electrical circuits or equipment will be needed in the shed in the future, it is wise to install a larger conduit or wire size than is currently required. This will make it easier to add new circuits or equipment without having to dig up the entire trench or replace the existing wiring. It is also a good idea to install a junction box or pull box at a convenient location along the underground wiring run. This will provide easy access to the wires for future maintenance, repairs, or upgrades. The junction box or pull box should be rated for underground use and should be properly sealed to prevent moisture from entering the system. When backfilling the trench after installing the underground wiring, it is important to use a suitable material, such as sand or gravel, that will not damage the wires or conduit. Avoid using sharp rocks or debris that could puncture the insulation or crush the conduit. The backfill material should be compacted in layers to provide a stable and even surface. Also, consider the potential for future landscaping or construction in the area. If there is a possibility that the trench could be disturbed by future digging or construction activities, it is important to protect the underground wiring with a concrete slab or other physical barrier. This will help to prevent accidental damage to the wires or conduit. Consider using ground fault circuit interrupter protection. Ground fault circuit interrupters are devices that detect small amounts of current leakage to ground and trip the circuit breaker, preventing electrical shock hazards. Ground fault circuit interrupters are required in many locations, such as bathrooms, kitchens, and outdoor areas, and it is a good idea to install them in the shed as well. Ground fault circuit interrupters can be installed in the electrical panel or at individual outlets or fixtures. Finally, document the installation. Keep a record of the type of wire and conduit used, the wire size, the burial depth, the location of the underground wiring run, and the date of installation. This information will be helpful for future maintenance, repairs, or upgrades. It is also a good idea to take photographs of the installation before backfilling the trench. These photographs can be used to locate the underground wiring run in the future and can be helpful for troubleshooting any problems that may arise. Remember that electrical codes are constantly evolving, so it is important to stay up to date on the latest requirements. The National Electrical Code is updated every 3 years, and local jurisdictions may also have their own amendments or interpretations. By following these guidelines and consulting with a qualified electrician, one can ensure safe and compliant underground wiring installation for the storage shed.